It's a simple question. It's the kind of thing you might ask on a clear night looking up at a sky full of stars. Where is everybody? It's a question that physicist Enrico Fermi supposedly asked his colleagues over lunch one day in 1950. The story goes that they were talking about UFOs and the possibility of alien life. After a bit of back and forth, Fermi just blurted it out. If there are aliens, and if some of them have been around for millions of years longer than us, why haven't we seen them? Where are they? And that's the heart of it. That's the Fermi Paradox. It's a conflict between an argument of scale and a lack of evidence. On one hand, the numbers seem to demand that the universe should be teeming with life, even intelligent life. On the other hand, we have nothing. No signals, no ships, no alien ruins on the moon. Just silence. A big cosmic silence. Let's break down the first part of that. The argument of scale. The universe is big. It's hard to really feel how big it is. Our galaxy, the Milky Way, has somewhere between 100 and 400 billion stars. That's just ours, and there are maybe 2 trillion other galaxies out there in the observable universe. 2 trillion, each with billions or even hundreds of billions of stars. The total number of stars is something like a 1 with 24 zeros after it. It's a number so large, it doesn't really mean anything to us. It's like trying to imagine eternity. Now, think about planets. For a long time, we didn't know if other stars had planets. It was just a guess. But in the last few decades, we've found thousands of them. We've learned that planets are not rare, they are common. It seems like most stars have them. And a decent chunk of those planets are in what we call the habitable zone or the Goldilocks zone. Not too hot, not too cold, just right for liquid water to exist on the surface. Liquid water is, as far as we know, a key ingredient for life. So, you take this absurdly large number of stars, multiply it by the high chance of them having planets, and then multiply that by the decent chance of some of those planets being in the right place for life. The final number is still huge. Even if life is a 1 in a billion chance, that would still mean there are billions of planets with life on them in the universe. And in our galaxy alone, there could be thousands or even millions. But there's another factor: the time. The universe is about 13.8 billion years old. Our planet, Earth, is about 4.5 billion years old. Life on Earth started pretty early, but complex, multicellular life didn't show up until much, much later. Humans, in our modern form, have only been around for a couple 100,000 years. Our technological civilization is just a few centuries old. We only started broadcasting radio signals into space in the last 100 years or so. We are cosmic babies. Imagine a civilization that started on a planet that formed 1 billion years before Earth. Or 2 billion. What would a civilization with a billion-year head start look like? It's impossible to comprehend. Think about the difference between us and people from the year 1000. Now multiply that by 1 million. Their technology would be like magic to us. They would have had plenty of time to solve problems like interstellar travel. Even at slow speeds, you could cross the galaxy in a few million years. That sounds like a long time to us. But on a cosmic timescale, it's nothing. A blink of an eye. If a civilization wanted to colonize the galaxy, it could. One way to do it would be with self-replicating probes, sometimes called von Neumann probes. You send a smart robot to a nearby star system. It uses the local materials, like asteroids and dust, to build a new factory and make copies of itself. Then those copies fly off to other star systems and do the same thing. It would be like a chain reaction. The math shows that you could explore and settle the entire Milky Way galaxy this way in about 500,000 to 10 million years. So, if there was just one civilization in our galaxy's history that decided to do this, they should be everywhere by now. Their probes should be in our solar system. We should be able to see their superstructures, their industrial waste, their signals. The galaxy should be noisy and bright and full of signs of intelligent life. But it's not. It's quiet. That's the paradox. The universe is old and big enough that it should be full of life. But when we look, we see nothing. So where is everybody? This question leads to a lot of possible answers. Some are hopeful, some are logical, and some are just terrifying. They generally fall into a few categories. The first category of answers suggests that intelligent life is just really, really rare. Maybe we are the first, or one of the first. This is the idea of the Great Filter. The Great Filter is a concept that says there is some hurdle, some barrier, that is incredibly difficult for life to get past. There's a sequence of steps life has to take to get from a dead rock to a galaxy-spanning civilization. It starts with the right star and planet, then life has to begin in the first place. Then it has to become complex. Then it has to develop intelligence. Then it has to develop technology. Then it has to survive long enough to spread beyond its home world. The Great Filter is one of these steps. It's a step that is so unlikely, so hard to overcome, that almost no one makes it through. The big question is, where is the filter? Is it behind us or is it in front of us? If the filter is behind us, that's good news. It means we've already passed the hard part. Maybe the hardest step was the very beginning, the jump from non-living chemistry to the first, simple self-replicating cell. We still don't know how this happened on Earth. We can make amino acids in a lab, but we can't make life. Maybe the conditions required are so specific, so astronomically unlikely, that it only happened once in this entire galaxy, on our planet. Or maybe the filter was the jump from simple prokaryotic cells to complex eukaryotic cells. That took over 1 billion years on Earth. 1 billion years of single-celled life doing not much at all. Maybe that jump is the bottleneck, or maybe the filter is the development of intelligence itself. Life on Earth has existed for almost 4 billion years. And as far as we can tell, only one species has ever developed the kind of technological intelligence that can contemplate space travel. Maybe that's the rare event. If the Great Filter is behind us, it means we are special. We are rare. We might even be alone in this galaxy. It's a lonely thought, but it's also a hopeful one. It means the future is ours. The silence is there because we are the first ones to be able to make any noise. But what if the Great Filter is in front of us? That's a much darker possibility. This would mean that life starts easily. Intelligence evolves all the time. Civilizations pop up all over the galaxy. But something always stops them from getting much further. Something always wipes them out. What could that filter be? The most obvious candidates are things we invent ourselves. Nuclear war, a genetically engineered plague that gets out of control. Runaway nanotechnology that turns the whole planet into gray goo. Artificial intelligence that becomes super intelligent and decides it no longer needs its creators. Or maybe it's a more gradual self-destruction, like wrecking your planet's climate until it can no longer support you. If this is the answer, then the silence we hear from space is a warning. The sky is full of the ghosts of civilizations that reached about our level of technology and then failed. They all hit the same wall, and we are rushing towards that same wall right now. It means we might be doomed, and there's very little we can do about it. It means intelligence isn't a long-term survival trait. It's a brilliant, short-lived flame. This is a sobering thought. Every time we read news about climate change or international tensions or the risks of new technologies, we could be looking at our own great filter in action. The silence of the universe could be the sound of a cosmic graveyard. So that's one whole category of possibilities. Something stops life from getting to the point where it can be seen. Either it's too hard to start or it's too hard to survive. But there's another category of answers. These answers assume that aliens are out there. They exist. They just have very good reasons for us not seeing them. One of the most famous ideas here is the zoo hypothesis. The idea is that the galaxy is full of advanced civilizations. They know we're here, but they are treating us like a nature preserve or animals in a zoo. They have a strict rule look, but don't touch, don't interfere with the primitive culture on Earth. Let them develop on their own. Why would they do this? Maybe it's a moral or ethical code. The Prime Directive, if you're a Star Trek fan. They believe it's wrong to interfere with a less developed civilization. Our culture, our science, our religion would all be shattered if a giant spaceship landed tomorrow. Maybe they are waiting for us to reach a certain level of maturity, a certain technological or ethical milestone. Once we pass that test, they'll welcome us into the Galactic Club. It's a nice idea. It makes us feel special and protected, but it has problems. It would require every single alien civilization to agree to this rule. All of them. For millions of years. Think about how hard it is to get all the humans on Earth to agree on anything. Now, imagine trying to enforce a single policy across thousands of independent alien species, each with their own biology, psychology, and history. All it takes is one dissenter, one civilization that doesn't care about the rules, to break the silence. And we haven't heard from them either. A related idea is that they are here, but we can't see them. They are so advanced that their technology is indistinguishable from nature or magic. Maybe they exist in other dimensions. Maybe they've uploaded their consciousness into a computer the size of a sugar cube. Maybe their biology is so fundamentally different from ours that we wouldn't even recognize them as life. We're looking for carbon-based life that uses water. What if there's silicon-based life that lives in liquid methane? What if there are beings made of pure energy that live in the plasma stars? We are looking for things that look like us. That might be the problem. Or maybe their communications are too advanced. We are scanning the skies for radio waves. That's like looking for smoke signals in the age of fiber optics. Maybe advanced civilizations use something we can't even imagine yet. Some neutrino signals, gravitational waves, some kind of faster than light communication that our physics doesn't even allow for. We might be listening with a tin can and a string while the real conversation is happening on a network we don't know exists. We are deaf and blind to the real universe. Then there's a much more frightening reason for the silence. This one is called the Dark Forest Hypothesis. It comes from a science fiction novel by Cixin Liu, but it's a powerful answer to the Fermi Paradox. The hypothesis goes like this. Imagine you are a lone hunter in a dark forest at night. The forest is full of other hunters. They are all like you, silent, paranoid. You can't see them, and they can't see you. You hear a rustle in the leaves. What do? Do you call out, "Hey, is anyone there? I'm friendly"? Probably not, because you don't know who or what is out there. You don't know their intentions. They might be friendly, or they might see you as a threat or a resource. The safest thing to do is to stay quiet, to hide. But what if you see another hunter light a fire? Now you know their exact location. You still don't know their intentions. Are they a friend or a foe? You can't risk it. The other hunter might be more powerful than you. If you reveal yourself to them, you are putting your survival in their hands. The only truly safe option is to eliminate the threat before they can eliminate you. So you shoot at the fire. The universe in this view is the dark forest. Every civilization is a hunter. The basic laws of survival in a universe with limited resources dictate that you stay hidden. You never ever reveal your location, because if you do, other, older, more powerful civilizations will notice you. And because they can't be sure of your intentions, and because you might one day become a threat to them, the safest and most logical course of action for them is to wipe you out. Just in case. This would explain the silence perfectly. The silence isn't an absence of life. The silence is the sound of everyone hiding. The only civilizations you see are the stupid ones who just lit a fire by, for example, broadcasting radio signals into deep space for 100 years. We might be those stupid ones. In this scenario, the universe could be full of life. But it's a life based on fear and paranoia. It is a terrifying thought. It suggests that if we ever do get a message from space, we should be very, very careful about answering. There are other, less dramatic possibilities for why they might be quiet. Maybe interstellar travel is just too hard. It's expensive, it's dangerous, and it takes a very long time. Maybe most civilizations look at the vast distances between stars and just say, no thanks. Why spend 1,000 years and all your resources sending a few people to a barren rock when you can build a perfect virtual world at home? Maybe advanced life doesn't expand outwards into physical space. Maybe it expands inwards into digital space. They could have created simulated universes so rich and compelling that the real physical universe seems dull and pointless by comparison. Or maybe they're just sleeping. This is the astivation hypothesis. It suggests that as the universe gets older, it also gets colder. The laws of thermodynamics say that computation is much more efficient at colder temperatures. A super advanced civilization might realize that they can get vastly more thinking done and live for vastly longer subjective lifespans if they just wait. So, they put themselves into a state of hibernation, planning to wake up trillions of years in the future when the universe is much colder and more efficient for their kind of post-biological existence. The universe seems quiet to us because the adults are all asleep, waiting for a better time to be awake. And finally, we come to the last major category of answers. This one is perhaps the simplest and in some ways the most profound. Maybe we are just alone. This is the rare earth hypothesis. It's a bit like the great filter idea, but it focuses on all the little things that had to go right for us to be here. It's not just one big filter. It's 1,000 small ones. For a planet to support complex life like us, you need a lot of things. You need to be in the right kind of galaxy. Not too close to the galactic core where there's too much radiation and supernovae going off all the time, but not too far out in the galactic suburbs where there aren't enough heavy elements to build rocky planets and people. You need the right kind of star. Not too big, or it will burn out too quickly before life has a chance to get complex. Not too small, or your planet will be tidally locked, with one side always facing the star, baked, and the other side frozen. Our sun is a relatively stable, long-lived star. You need to be in the right orbit around that star, or the Goldilocks zone. A few million miles closer, and our oceans would boil away. A few million miles further out, and they would freeze solid. You need the right kind of planet. A rocky planet, big enough to hold onto an atmosphere, but not so big that it becomes a gas giant. It needs a molten core to generate a magnetic field, which protects the atmosphere from being stripped away by the solar wind. You need a big moon. Our moon is unusually large compared to our planet. It stabilizes our axial tilt. Without the moon, Earth would wobble on its axis like a spinning top that's about to fall over. This would cause catastrophic changes in climate over thousands of years, making it very hard for complex life to get a foothold. You need plate tectonics. The shifting of continents is crucial for regulating the planet's temperature over geological time through the carbon cycle. It also creates different environments and drives evolution. You need a gas giant in the outer solar system. Jupiter acts like a cosmic bodyguard for Earth. Its immense gravity helps to sweep up or fling away comets and asteroids that might otherwise hit us. The impact that killed the dinosaurs was bad enough. Imagine that happening every few million years. The list goes on and on. The right amount of water, the right atmospheric composition, the right timing of evolutionary leaps. When you start adding up all these requirements, all these lucky coincidences, maybe the odds of getting a planet exactly like Earth are so low that it has only happened once in this galaxy. Thus, this is a lonely thought, but it's also a precious one. If we are the only thinking beings in a galaxy of 400 billion stars, that makes what we have here on this little blue dot infinitely valuable. It means there is no one coming to save us from ourselves. It means we are the sole guardians of consciousness in this vast, empty sector of the cosmos. The hopes and dreams of the galaxy might be resting on our shoulders, so what is the answer? We don't know. The Fermi Paradox is a paradox precisely because we don't have enough data. All we have is one data point, us, and it's very hard to draw a line from a single point. Each of these possible solutions is a mirror. It reflects our own hopes, our own fears, our own ideas about what it means to be a civilization. When we worry about the great filter being in front of us, we are really talking about our own anxieties about nuclear war and climate change. When we dream about the zoo hypothesis, we are hoping that there are wise, benevolent parents out there watching over us. When we contemplate the dark forest, we are projecting our own history of conflict and mistrust onto the stars. And when we consider the idea that we are alone, we are grappling with our own feelings of cosmic significance or insignificance. For now, the silence remains. We are still listening. Projects like SETI, the search for extraterrestrial intelligence, have been scanning the skies for decades, and so far, they have found nothing but static. But the search continues, and our tools get better every year. The James Webb Space Telescope might be able to detect biosignatures in the atmospheres of distant exoplanets. Maybe one day we'll find signs of methane and oxygen in the same atmosphere, a chemical imbalance that could be a strong sign of life. That wouldn't tell us if they are intelligent, but it would tell us we are not alone in the biological sense. And that would change everything. Until then, we are left with the question, this huge, echoing question mark hanging over all of human history and our future. It forces us to look at ourselves. Are we a civilization that will pass the great filter? Are we a species that is worth talking to? Are we good stewards of the only known life in the galaxy? The silence of the universe is not just an absence of noise. It is a presence. It is a challenge. It asks us who we are and what we're going to become. And we don't have an answer for that either. Not yet. All we can do is keep looking up at the sky and keep asking the question. Where is everybody?